Hello, sir. Good afternoon.
Yeah, good afternoon. Good afternoon, all the students and the coordinators. I hope students are joining, right? Hello, madam. Hello, madam. Can you hear me? Hello.
Hello, sir.
Yeah,
Hello.
students are joining.
Yes, sir.
Yes.
I'll share them the link. Yeah.
Yeah. You have shared, right?
Yes, sir. I'm sharing, sir. Yeah.
Yeah. Hello, madam. I can start, right?
Yes, sir. You're audible, sir. Yeah.
Yeah, you can start.
Yes, sir. It's audible. Yeah.
Yeah, students are joining. Hello.
Yes, sir.
Then Karthik can start.
Yes, sir. I'll share my screen. Just give me a moment.
Yeah, sure. Because we are waiting. The students are. Yeah. Okay, you can share.
Yeah, I can start as soon as I get a go. If we can, I can wait also. That's not a problem. If let's see if all students have joined.
Yeah, you can share your link. By that time, they will also join.
Yeah, I
Another
have
2 3
shared my
minutes.
screen.
Yeah. Okay.
Sure, sir. I have shared the screen. Ma'am, can you confirm that my screen is visible?
No, Karthik, I believe it is not visible.
Okay, let me just reshare it. Yeah, I hope my screen is visible now, sir.
Now it is.
Okay, great. So I'll start, sir.
Sure, sure.
Sure. Thank you. Good afternoon, all. Let's continue our session from yesterday. Yesterday, we looked at Python, the basic what identifiers are, what are the keywords in Python, how does a statement and comments and things like that, the basic building blocks of Python. And then we looked at the different types of arithmetic operators, like arithmetic, relational, logical, bitwise, kind of operators. Then we looked at special kind of operators called membership operators and then identity operator, and a couple of built-in functions like ID and type functions. We had a glimpse of them. Then moving forward today, let's look at control structures in Python. So what exactly are these control structures? Control structures are any mechanisms or statements that is used to control the flow of the program, right? It can be looping, it can be branching statements. All these things comes under control structures. The concepts of branching and looping remains the same. However, the syntactical changes are there. When you compare it with other languages, you have if else if loops, else if statements, then loops like for loop, while loop, right? You have all these things, the continue and break, the branching statements. You have all of them, the similar to Java or C or C++. However, the syntaxes differ, which we will be stressing on. I will be stressing on the syntax, right? Not the workflow or how do they function, because since you guys are in HM, I think you would have a fair idea about how these control structures behave when you put them in the program, right? The very first is before we understand control statements, right? We have to understand one thing. In Python, there are no brackets that you use to write, you know, blocks. For example, in C, you write like this, right? Void main. Then you start a block with a pair of flower bracket. You indent and then go on declaring, program. Like this, printf, so on, so on, so. So basically, you write the block inside a set of flower brackets. So that's what you do even if you write any of the control statements. Like if there is some condition, right, then you basically put the body of the if inside a block like this in flower bracket, and you write the code inside this flower bracket inside the if, right? So this is the block uh, in a program, and these blocks are identified in C program or in Java kind of languages using the flower brackets. However, in Python, we don't have anything of that sort. Then how do we define blocks? We define blocks using indentation, right? Indentation is very crucial in Python, because even if you give a single space, it is treated as a separate block of code. I'll give you an example here in the slide. Look, you have two statements here, print true and x, and then you have an else where there is one statement. There is one statement which is completely out of this if or else statement. This is in the this out of it out of if block statement is basically there was supposed to be a print here. Please consider it to be print, right? So you basically give an indent to write a block. Now you write all the lines like this. Somewhere you have to check what is the value of x. If x is greater, you want to print the value of it. If not, you want to print the value, Oh, the print has gone up here. This should come down here. That's the small mistake in the slide. Kindly do not get confused. In clarifying, this print doesn't come here. This print will come here. Right. Now, once you write if, you give the colon. You can include the condition inside a bracket, or it's okay if you don't include it also. But once you want to start a new block, you give a colon. Right after that, you indent the next line and further until you finish the block. Right? If this if had 5 lines, then all these 5 lines would have the same amount of indentation. But however, in this example, the if statement has only 2 lines, so both of these lines are indented by one tab space. You have the tab button in your keyboard, right? So this is basically one tab space is an indentation. This indentation says that since these two are at same level, this will be considered as a block of code. Let's say there are 2 lines here. These 3 lines are considered as a block of code. Now, once this block is over, you want to come out of, you want to write the code which is out of the if statement. Then what do? You go back from the indentation. You start the next line right here at the level of if. So that means this else is at the same level as that of if. So this comes under this indentation, this block, right? Then this else, the body of else is also written with a single tab, and after else there is a colon, which means that you're going to write a block. All the indentation is over. Once you are done with the indentation, the next line of codes will be considered the block same as that of the if statement. So like this, you write your code in an organized, indented way. So indentation or spaces or tabs are very, very crucial in Python. Without the indentation, your Python interpreter will get confused. It will not execute the logic in the way you expected it to be, right? Now, this is how it is. Let's say there is a block. You are right now at a particular block. You want to start a new block, so you give one indentation. Inside this block, you want to start one more block, so this you give one more indentation. Let's say this is a function, right? You have given indentation. Somewhere here you are given an if, so you give one more tab. So basically this is a 2 tab. One indentation is for the function, second indentation is for the if. So this block 3 comes under the body of if because of this indentation, 2 tab space. Then once you're done with the if you want to continue the body of the function, you go back by 1 tab space. So this block 2 continuation will be here. And now once you're done with block 2, you can go back to continue the block 1 or basically start a new block, right? So this is indentation, first level, second level, third level. Like this, you can go on defining different types of indentation, right? So if you have nested if a line, then again an if, couple of more lines, right? Like in C. Then in Python, what you do is you write if, you indent it. The body has 2 lines, and then one more if. The body of this has 2 lines. You must give colon here before starting a new block. Then once it is done, you continue writing all the lines that comes here at the level of the first if will be continued to written, here at this level. So this is indentation, the relevance of indentation in Python. It's very, very, very important, right? This is one of the common mistake that you tend to do when you start out with Python, when you start learning with Python. Once you get used to it, don't worry, you will be fine with it. Your autopilot will kick in if you practice enough, and you will be able to tackle this. Now, decision making statement that you have is like any common computer programming language is if, else, and else if statement. So if statement will check a condition, and if the condition is true, it executes a block of code under it. If not, it will go to the further statements, right? So the similar way, this is an example of to demonstrate the behavior of if. The x value is set to 8. This is the syntax. We give if condition colon and then a block. The statement is the body of if. Come back, else, if at all you have else part. If not, this is else part is an optional part. Else colon, in the next line you give a tab and you start the body of the else. All right. Now if x is equal to 8, set to 8, you are checking if x is less than 10. If true, you are printing the value. Then you are checking, you are assigning one more variable, and you are putting it to 10. And if the value is greater than 5, then you're putting out high as a print statement, right? And then you're printing an statement, I am out of if, at the level of this if. If you see here, this last printf statement has indentation same as that of the this line, this line, this line, and this line, right? So this belongs to the main body of the program. Now, because of both ifs are true, you would get the body of the ifs executed. The value of x is 8 will be printed, and the value of high will be printed. I am out of if will be printed. If the x value is set to 15, then the output will not have this statement. Your output will have only, apart from this statement, you will have hi, I am out of f. You won't get the value of x because it is not less than 10 if the value of x is set to 15. So that's the syntax of if and else. Similar to this, you write else also to whichever if you want to continue, right? Attach the else part with. Those should be continuous. You should not have any statements here at the level of if in order to write the else. If you have any statement here at the level of if, at the indentation of if, before writing else, then this else will be parentless, as in it won't be attached to any if, so you will get an error. Moving forward, the else if ladder, let's look at that. So else if statement is used when you have multiple statements to be checked that you guys would know already. This is a typical example where you are verifying if the value is greater than 10 or less than 10. If not, if they're equal, you want some statements to be printed. Please notice the syntax here. Once the if condition is given, the body, these two statements of if, has an indentation, right? And the if ends with a colon, meaning a block is getting started. Once you come back to the level of this same indentation, one tab back, you can continue with the if rest of the statement, that is else if or else, or you can continue with the remaining part of the program. So here you don't use, like in C or Java, you don't use else space if and then condition. Here you use a keyword called elif and then condition. So you don't use else if, you use elif without a space like it is shown here. Elif, if variable is less than 10, you will print hello in Spanish, and then you will print the value. Here you're printing hello in English, and then you're printing the value. If it is not less than or greater, if it's equal, it will execute the else part, it will print hi with the value, right? Now, this end of the program is completely out of if statement belongs to the main block of the program. Now, on the output, like looking at the var value, since it is equal to 10, the statement which will be executed when the value is equal to 10 is the else statement, because the 10 is not greater than 10 or less than 10. So you go to the else part and hi, and 10 will be printed, and then end of the program will be printed. So the output is given as hi, 10, and end of the program. So you must note here, in Python, we don't have any switch case statement. You do not have switch case statement. If at all you have a scenario switch case kind of situation, you will have to use elif ladder. Now, in the last yesterday's class, I showed you a declaration and printing the amount of bill, right? Bill value, customer ID, and yeah. We looked at a small activity of declaring a variable, initializing it, declaring it, initializing it, and then printing it, right? So let me check if it is the same value that I have put in. Did we change the program yesterday? I don't exactly recall. Let's have a look. Oh yeah, we have this. So in today's activity, let's continue on this. And so we have bill ID initialized, customer ID, and bill amount initialized, and the values are being printed. Let's try and do this. Yeah, this. Let's try and see if the bill amount is fitting in is greater than 1,000. 5% discount should be given on the total amount. If not, if it is between 500 to 1,000, 2%. If not, 1% discount should be given. Let's try and put that. Okay. So bill amount is, let's take it as an input. Int user input. Int input, enter bill amount. So I'm going to take it like this. I've converted it into integer. Now we have to give discounts according to the bill amount, whatever it is. So if I have the bill amount is greater than 1,000, if bill amount is greater than or equal to 1,000, then I'm going to set. As soon as I give colon, since it's in Python, ideally I shell, As soon as I give colon and press enter, you see it shows the cursor after one tap automatically. So that's a new block that you're going to start because you have given a colon there. If you see I don't have a colon, it won't start a new block. So colon indicates a new block here. So I'll set my bill amount is equal to bill amount. How much is the discount? 5 is the percent is the discount. So let me set it to 0.95. I'll multiply it with 0.95. Similarly, I'll use LF. My bill amount is between 500 to 1000. Bill amount is greater than or equal to 500, and bill amount is less than 1000, then I am going to give 5% discount. Sorry, 2%. Bill amount is equal to 98% of the amount. So bill amount into 0.98. Else, I have 1% discount to be given. Let me copy this statement. Nine, 1%. Once I am out of the else part, I will be printing whatever the bill amount has been calculated. I'll be printing the output. Let's try and execute this. Sorry. CD desktop programs, and I'm going to use Python first Python program.py. Ask me to enter the bill amount. Let me enter 1000 rupees. It gives me 5% discount of, and the amount is 950 rupees. If the amount is between 500, then it should give me 2% of discount. So you see the bill amount is 10 rupees has been deducted, and if I give it less, 1% discount will be given 99 rupees. 1 rupee discount has been given as 1%. So this is a small program to demonstrate the if else ladder for you. Then moving forward, we have iterative statements or looping statements. So in order to understand this, let's look at one by one with examples. We have loops like while loop and for loop, and we also have auto range of value generation function called range. I'll be telling you what the range is, and then we have the flow control statements like break and continue, and there is a passive line filler statement called pass. I will be telling you about that as well. So let's look at them one by one. Here we have while loop. The while loop is same as the C or a Java while loop, where while we give a condition, if the condition is true, it executes the body of the loop continuously until the condition becomes false, right? So here is a typical syntax of while loop. While condition, we give colon, start a new block, write the body of the while. So this gives us the while loop. So that's the syntax. So here towards the left hand side, we have a small example of while loop, a pretty typical one, iterating the value. A variable is set to 5. and we check if the variable is greater than 0, and we are going to print that I am in iteration x, the variable value, decrement it. Keep doing it until the variable value becomes 0. Now the first iteration, we have var is equal to 5. It will print I am in iteration 5. Then you got this as this first line as the output. Then variable value decrements by 1. So I am out, sorry, you go back to the loop and you check with value var is equal to 4. So you print iteration 4, 3, 2, 1. You keep on printing it. When var value is 1, the var value gets updated here. After printing I'm in iteration 1, it will update var to 0. And once you go back to check the condition, var value will not be greater than 0. Hence it will come out of the loop and it will print I am out of while loop. So here, it should print I am out of while loop here. It's not been given, is it? Yeah, it's not been given. All right. So there is another small example here where if statement is nested inside or used inside while loop. So if var is same program, just that if var is equal to 2, you are breaking out of the while loop. Break statement usage is as same as how you used to use in C, just that there is no semicolon here, right? So var you are going to use when var is equal to 2, you will break. If not, in the same body, you are saying I am still in while loop, right? So at var is equal to 5, you will print I am in iteration 5. Var becomes 4. Since it's not true, you won't go to the body of the if. It will print I am still in while. So at var is equal to 5, it will print I am in iteration 5, and it will print I am still in while. So these two lines. Var is equal to 4 also same case. Var is equal to 3, it will also do I am in iteration 3. The var value becomes 2, and it will come here. Since if is equal to 2, it will break out of the loop. It won't give I am still in while, but at iteration value, when it prints I am in iteration 3, var value becomes 2, and it will break out of the loop and tell I am out of the while loop here. That's a typical usage of break statement. You use break statement to come out of the loop, right? Then comes for loop. For loop is might be in the beginning, until you practice probably, or until you understand neatly, might be confusing, because the for loop here is slightly different, right? What for loop does is, for loop takes two inputs: a variable that is used for iteration, and then a sequence of iterator values. As in, you can take for I, then you use a inbuilt statement called in. So this inbuilt statements for and in are syntax of for loop. So these must be there. The iterator value variable what you have taken here, this can be any variable. You can use it. You don't have to initialize it to anything also. You can just straight away use it. Then you use a set of values here, right? It can be in a bracket, need not to be in a bracket, or you can give anything. If you want the loop to run 5 times, you just give 1 comma 2 comma 3 comma 4 comma 5. So what this will do is, if you have 3 lines in the body of the for, I value will be in the first iteration assigned to value 1. With I value is equal to 1, you will run this loop. The body is run once. Then you will go back to I value. It will pick up the next value. I will be initialized to 2. This body will be run with I value as 2. Then you will pick it up with I is equal to 3, 4, and 5. Like this, the loop will run until I is assigned with all the values in the sequence that you have given here, right? course there should be a colon at the end of the sequence. A small example that has been given here for counter is a iterator variable. Instead of I, the variable that has been taken is counter. In a value set of values is being given separated by comma. This is combination of number, string, and everything. I gave you an example of a sequence as number. This sequence can be heterogeneous in nature. That is, it can contain any type of data type, right? 1 comma 2 comma a string sita comma 7 comma string ram comma 5 has been given as the sequence. Then a colon has been given, and you print the value of the counter. So in the first iteration, the counter value is assigned with 1 here. It will print what the value of counter is. So you get output is 1. You go to the next iteration, the value of counter will be initialized to the second value in the sequence. 2 will be printed. Third value will be sita, the string. It will be printed like that. 7, ram, and 5. So this for loop will run until counter is initialized with all the values in the sequence. I hope I'm clear here. Now this is for loop. For loop here specifically has been designed to run with respect to any kind of values that you want, not just the integer values to iterate it over iteration variable integer value, like int I less than 10, I plus plus. We don't really have to do this, right? What if I want to use that? What if I don't want to write, like, what if I want the for loop to run 100 times, right? Like, for example, I want to use for loop I is equal to 0, I less than 100, I plus plus, the for loop in C. What if I want to run it like this? How do I get this? For this, what you have to do is you have to write for I in sequence of numbers 0 comma 1 comma 2 comma 3. You go on like this until you have 99. So you can do this, right? And then write the body of the for loop. You might wonder, how is that possible? What if I want to run my for loop million times? Do you expect me to write million numbers here? Actually, no. To facilitate this kind of iteration, right? For loop gives, Python gives a special function called range, right? What this range does is, range generates a sequence of numbers. So you can basically give for I in range of 0 comma 100. If you give this range of 0 comma 100 will generate a sequence. This range of 100 0 comma 100 will replace a sequence of numbers starting from 0 100 digits, that is up to 100, 0 comma 1 comma 2 comma so on up to 99. So that way, when you write for I in range of 0 comma 100, it is equal to writing C for loop of I is equal to 0, I less than 100, I plus plus, right? Now, what if you want to tell that, sir, I don't want to increment my iterator by one value, I want to iterate it by two values. That is, I want to write it like for I is equal to 0, I less than 100, I is equal to 0, semicolon, I less than 100. I want to do I plus equal to 2. I want to increment it by you know 2 values, 2 units at a time. In this case, what you can actually do is you can give a step in range. By default, the step is considered as 1, so it increments by 1, but you can later change the step as a third parameter by passing hold on please. Comma 2. So if you give like this, what your range will actually do is, in this case, it generates sequence of numbers starting with 0, skips 2 values. So next it increments it by 2, then increments it by 2, increments it by 2. Like this, it will keep on doing it until it reaches number less than 100. In this case, it might reach 98, all even numbers, right? So you go up to 98 like this. So it automatically generates sequence of values. That's the importance of range. So range has been given in order to accommodate this kind of automatic iteration, if at all you want to do. If you don't want to use range, you can iterate the for loop over a set of values. For example, if you want to do some kind of analysis for every user, right? Then what you can do is you can, instead of writing an array, taking all users in the array and then writing taking index and then taking the array, fetching it the user name using the index, you can give the set of all users here, and the counter will run over all the users. For first username, do the thing, do the execute the body. For second username, do the body. Third username, run the body again. Fourth username, run the body again. Like that, for all usernames it will pick it up, right? So that's the advantage, or that's the extra power that the for loop in Python possesses. So this is just an example of how row works. So here is it. Range has 3 parameters: lower limit, upper limit, comma, increment or decrement. If you don't give this third increment value, it will automatically increment, right? So here is the value of it. If I write for value in range 1 comma 6, then under the body, if I write the print value here, this should actually be in the body indented. You can't write like this straight in the same line. It prints 1 2 3 4 5. If you give two step as 2 here, then it prints all the even numbers starting with 0 up to 6, that is less than 6, which is 4. If you want to run it up to 1 with decrement value set as -2, then it starts at 6, decrements by 2 4, decrements by 2 2, and since it is less than 1, it's greater than 1, you stop at 1. You don't exactly go to the end value, but just before that you will stop, right? And like this is the beauty. You just observe this for loop here. For ch here stands for character in hello world, right? So when you give a string like this as the sequence, every character is picked up as the sequence here, right? The element of the sequence here. So first iteration runs with h value, ch is equal to h. Next will be running with e, next will be running with l, next will be running with l, next will be running with o. Like that, you continuously pick up one letter and then execute the body of the for loop here. Now, what is the body of the for loop that it contains? Here, what you're doing is you're using the character variable dot upper as a function. This character dot upper converts the character irrespective of whether it is uppercase or lowercase into uppercase, right? We will look into this dot upper function in a while. So basically every letter that it picks up, it will convert it into capital letter, right? Just a small logic of how we can use iteration in for loop. So that covers the range function and the for loop. Then the break statement, I already showed you how the break works. This is the same example that is being used. So break is used to come out of the loop whenever it is necessary. Continue also is same. Continue is used just like the statement. The complete statement will have the keyword continue. It is used to skip the current iteration of the loop the way we use it in any other programming language, right? You can use this break and continue in both while or for loop. It doesn't matter. It just skips the breaks out of the loop or skips the iteration in the loop. Then comes pass statement. Now, let's say that you have a program that is running
Hello? Hello? ಏನಾಯ್ತು ಇಂಡೇಟಾ ಓಕೆ
Am I audible?
Yes, sir, you are audible, sir.
Okay. Sorry, ma'am.
Yeah,
Sorry
it's
about.
okay. No problem, sir. Yeah.
Let me just share my screen quickly. I hope my screen is visible, no, ma'am?
Yes, sir, it's visible.
All right. So let's say that somewhere in your program you want a placeholder to be placed. Pass doesn't really have much in relevance, but if you want some kind of a construct to be there, but you want the logic to be added later in some time for future implementation, then you can just use pass. Pass is a dummy line of statement which doesn't actually execute, right? So you have X is set to joy, but you don't know what to do when joy is value X is joy. If John, you would want to print the name of the John. If else, you would want to print that it is in else. But if joy, you don't know what to do, you want to implement it in the future, then what you do is in the body of else, if LF X is equal to joy, you put a pass. Basically, pass is a placeholder kind of a line, right, for you to implement in future. That you can consider. Then moving forward to the data structures in Python, right? This is pretty interesting topic, because Python offers comparatively some kind of specifically unique or kind of different than what other languages offer. Kind of inherent or inbuilt data structures it offers are quite different when compared to the other C or Java kind of languages. Let's go look at the different kind of data structures that we have. Your Python provides data structures like string, list, tuple, sets, and dictionaries. These are the 5 different data structures Python readily offers. All right. Now let's go look at what these are one by one. Strings, you already know. Uh, Strings are basically sequence of characters, right? So Python accepts string by, you can basically tell a string as this, hello, in single quote, right? Or a double quote, or you can also tell it in single quote. It doesn't matter. Single or double quote you can use, right? Now whatever type of quote you start with, you must end with the same thing. You can also use triple quote, hello, but you just have to end with these triple quotes. Now this string is considered to be let's say you have s is equal to a string assigned hello, like this. Then you can basically refer it like the array index, right? You can give s of 0. S of 0 gives h. S of 1 gives e. L gives 2. L 3, like this. You can basically use the index to refer them, right? Now another nice thing about Python is that you can actually use inverse negative number as index. S is equal to hello I have taken. Now if I give print s of 1, it gives me e, right? Like this I can basically gives me o. Now if I use -1, it starts referring in a reverse order. That is, if I have hello written like this, this is -1, this is -2, this is -3. You can go referring to the indexes like this. I'll show you that. See, S of -1 is the last letter. S of -2 will be last second letter, which is L. 3 will be the last third letter, which is again L. S of 4 will be this, right? And then there is something called as slicing, as in you can slice a string or any data structure for that matter, especially strings and lists. What you can do here in slicing is you can take a substring of this. For example, I can give S of 0:3, meaning I want a substring to be extracted from S, and the substrings to start from 0 index and go up to third index. So 0, 1, 2, 3, which is second L, right? You start with 0, start with H up to 3, that is second L. So you get output as HEL, HEL, right? And if you go up to 5, you get the complete thing. You start from 0, you go up to 5, not the 5th. You don't have the 5th, right? The index is up to 4. Like that. If you don't give anything in the after the colon, it takes the complete string. Meaning, it takes from the beginning. H, it starts from 0, right? If you give for let's say 2 here, and then if you don't give anything, it starts from 2 to the end. So LLO, like this. This is called slicing. String slicing is an activity where you basically uh, you basically, when it's want to extract some portion of the data structure, but you don't want the complete element of what you have, then that is called as string slicing. So this slicing can also be applicable on other aspects. So this is a string in double quote, this is a string in triple quote, this is a string, though it has been used to indicate paragraph, sentence and word, it doesn't matter, be it double quote or single quote or triple quote, it's all the same. It is considered as string always, right? And there are some operations and functions that you can perform on strings. So what are these operations? If you have two variables called 1a, let's say hello, and b is equal to hi, then I can do a plus b. A plus b gives concatenation of both the strings, right? To repeat a star, some numeric value, it repeats the a string 3 times. Hello, 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 right? So this is one thing. Indexing, I already show you how to extract the specific element using indexing. Another operation is slicing. I showed you how to do slicing. And then comes the length function. So length function is basically a function that returns the length of the string. If I give b, it gives 2 automatically. These are all inbuilt functions and operations that you can do on strings. So you can use these to write any kind of string operations quite easily, right? You don't have to traverse through the array, copy that element to different array, extract them. You don't really have to do that. If you want to do any kind of string operations, Python strings are pretty simple, neat, and straightforward. Then we have something called as strip function. What this strip functions will do is, if your string has empty spaces at the end of the string or in the beginning of the string, then it removes those empty spaces. So if you have hello followed by some three spaces in double quote, if you do print str dot strip as a function, it removes the space here, right? Just the hello will be retained. Empty spaces will be retained, removed from the beginning and the end of the string. So that is strip function. Starts with function. Basically, if you use string name dot starts with some substring, if this string variable starts with this substring, then it gives true. If not, it gives false. For example, I'll use a dot starts, it gives false because it is starting with small letter. H true. So a, similarly you can use something called find. What find does is it returns the index, first index of where something occurred. For example, if you used a dot find o, it returns the index 4. O is that has hello, so it returns 2. That is, the first occurrence will be returned, right? And you can also give search after certain index. If you want to search after second index, L is found at 3, right? That is, you are starting from third index to search where is L, and where as soon as you started, you got L, it gave you this as it is present in position 3. So you can basically start from anywhere to find. If you don't give this second parameter, it starts from index 0 to search. Then you can also use upper, lower, and capitalized function. Upper will convert a case, right? Let me give b is equal to capital high. B, if I print, it is basically all uppercase. B dot lower gives lowercase. Similarly, A dot capitalize gives first letter in capital, the other things in smaller automatically. So you can basically use these functions to play around with formatting or editing the content of any of your document using strings, right? Now comes lists. So lists is basically the other type of data type. It is called ordered group of values enclosed in a square bracket. So ordered group, meaning the order that you give here matters. So in a square bracket, if you have values separated by comma, that becomes a list. 1, 2, 3, 4. Like this, you can give a list, and this list is taken as a data structure, and you can use it. And this list is heterogeneous in nature. What do you mean by that? Meaning, not always the content of the list should be of same data type. You can have content of the list of different data type. For example, I can use L is equal to 1 comma 2 comma then boolean value true comma uh, 3.2 or floating point number. I can give this. If I see the type of L, it tells values, ordered values. Why am I saying ordered? Because even lists can be used. L of 0 is 1. L of 2 is high, like this, right? You can refer them. And you can also create an empty list, right? List 1 is equal to, if you want the list to be like an empty array, you want to populate the content of the list in the future, then you can use like this. List, right? All the values should be comma separated here. Here, this is a list of all strings where each value is a type of language, name of the language. Then comes see, this is an list example. This is an empty list of numbers, list of mixed data types, list of strings. This is a nested list where the first element in the list is a list itself. This is the first element in the list, right? This is the second element in the list. Every element in the list, every comma separated element in the list is a list itself, right? And this is a deeply nested list. That is a list inside a list inside a list inside a list. So you can have data represented like this in Python. In list R, you can check the length of the list. You can concatenate the list using plus. You can repeat the list using integer into integer. Then you can check the membership. 7 in, this I showed you yesterday, right? 7 in the list name. For example, if this is look, I can give this 3.2 in L gives true, right? If I give 3 in L gives false. I can check membership like this. I can iterate through it. I can give a for I in L colon a tab uh, print I. So I can print it. I can do this. Then I can also index it. I told you how the list indexing can be done. Negative slicing or slicing can be done, as in L of I and true, right? Like this, I can slice it. I can also refer it with a negative index. -2 is the last second element, which is true. This is my list. So we can go on like this. Then come tuples. Tuples is basically again similar to list. Tuples are also ordered sequence of elements enclosed in normal bracket, not square bracket, right? Lists are in square bracket. You might ask me, sir, what is the difference? I will give P is equal to same thing, 1 comma 2 comma high comma true comma 3.2, right? Now I have L, which is a list. I have T, which is a tuple. uh, Type of T is tuple. I'm so sorry. this is basically, I'm reassigning it to a tuple bracket. Type of T is a tuple now, right? Now, I can basically change the content of L by saying, look, L of 0 is equal to, I can give 10. It entertains it. If I type L, 1 is replaced here with 10, right? Let's try and do the same thing with tuple. T of 0. It says tuple object does not support item assignment, meaning it's immutable. Once you declare a tuple, you can't change it. You have to convert it into list using some logic, and then you can change it, but you can't directly change the tuple element, right? So it is called immutability. Immutability means once declared, the rest of the nature of tuples is same like lists, just that it is immutable. Once it is defined, you can't change. You can change the content of the data structure anytime in the run of the program. However, in tuple you cannot do it, right? Now comes sets, unique element. Here order doesn't matter. You can't index them, right? Because unordered, there is no index value associated with it. But unique elements, even if you while declaring give duplicate element, it will filter and retain only one occurrence of the element. If you define a set like this, form a set, S is equal to 1 comma 1 comma 2 comma 3 comma 4. S if I print, see, though I have repeated one, it has taken only one occurrence of this. And I can't really have S of 0. This indexing doesn't happen. There is no order here, right? 1 comma 2 comma 3 comma 4 is same as S1 of 3 comma 2 comma 1 comma 4. S is S1, sorry, true. They both are equal. See, S and S1 are equal. Though their order is different, since they are unordered, S1, though I have created in 3 comma 2 comma 1 comma 4, it automatically took it in a different way. It doesn't matter. The order in set doesn't matter. So it's an unordered set, and you can perform operations on set. Two different set elements if you have. You can basically perform set operations like intersection, difference, union, cross product. These can be performed on the set. Two different sets, right? Like this. So length of set is given like this. If S is a set, then you can take the length of set. You can iterate through it. You can check if X is in S, an element membership. You can check. Is not. You can check. You can check if some element is subset of a set. If T is a subset of S, it will give true. If not, it doesn't give true. Superset also you can check. You can combine S and T using this operation. These are also equivalent operations. If these two objects are sets, then it checks subset and superset. So this combines. This is union. This is intersection between set S and T, right? So if I write S, I get an empty set. Intersection, sorry, right? And if I give union, there is or I get the same thing. Let me change S1 here. S1, let me change it to 3.2. One is 2 and 3. If I take this, only 2 and 3 I get. If I give union, I get everything. My S is 1, 2, 3, 4. My S1 is 3, 2. And if I apply intersection and union, I get this result. I can also apply set difference. Set difference I can give using this. Symmetric difference I can get. And I can also copy set into another set by using s.copy and giving the new set name. These are the data structure that we have is key value pair. Key value pair is the basically dictionary. It is called dictionary. Dictionary is in Python is given by flower bracket with key colon value pair, value comma second key comma colon, right? The value will be written. You don't have indexes like 0, 1, 2, 3, 4, but you can fetch them using the keys. So look at here. We have a phone book dictionary defined with John as some number and Jill as some number. So if you use phone book of John, it gives you the value of this number. If you give phone book of Jill, it gives you this number. So I will quickly rush through because I still have to do a small example on Raspberry Pi. I need time for that as well. So Python thing I will rush through a little. I have very little of it left now. Mutability and immutability, as I said, you can change the elements inside the data structure is mutable. If you can't change it in the run of the program, it's immutable. Strings and tuples are immutable, and list sets and dictionaries are mutable in Python. Then comes functions. Look, functions are basically organized some piece of code that you can call anytime in your program and it executes that logic, right? So you guys have written functions throughout your programming labs. Now, how do I define program? So there are two types of functions: built-in functions and user-defined functions. Print, input, type, ID, these are all built-in functions. User-defined functions, how do I write it? I'm going to show you that now. Function is defined using the keyword def, then name of the function, followed by list of parameters, if at all you have any, then colon. After colon, you are starting the block of the function. You are going to write the code of the function here. If at all you have a return value, you will return it. If you don't have any return value, you will return it. You do not anyway specify the return type of the function. Your Python automatically picks it up, right? So the body of the function should be indented, and you call the function using the function name, right? Def is the keyword that you use to define the function. So I'll show you an example here. Look at this. I am defining a function def print str, and I am taking some parameters some string as my input. I'm not giving any data type of this as well. Now, inside the function body, I'm having print. This function prints string passed as an argument, and you are printing the argument value. It doesn't matter if you return or not, the control returns. If at all you have anything to return, you can return it. If not, you don't have to return just for the sake of returning it. It will automatically return. And after this function body, I am calling ptr underscore str. That is the function name, passing some string, a sentence as parameter. So this calling the user defined function print underscore str1 is passed as it is, and it is copied into str1. So when you print it, the first line is printing this print statement. Second line is printing str1, which is this parameter that you have passed. So that's Python function for you. You can pass any data type. You can not just pass variables like integer variables, floating point variables, string variables. You can even pass all the data types, mutable and immutable data types like strings, booleans, tuples, lists, and dictionaries, right? Then passing an immutable data type. See this example. We have a function where you get CID as argument, you increment it by 1, and then you print it, right? So now the body of the program is, you have customer ID set to 100, you're printing that customer ID, then you are passing it inside to customer ID, right? Now once you pass it, once you are incrementing it and you are printing it, after returning again you are printing it. So once you can see it here, since the scope of this variable is the function, not the function scope, but the scope of this is the global scope. That is, this is part of the program body. Once you first time print it before the function call, it prints 100. Inside the function call, when you print it, it is printing the incremented value of 101. Once you come out of the function call, you lost this change. You are getting the customer ID back. You did not, your function did not actually change the value forever. It was only in that function logic you changed. This is basically the data type immutability, meaning the data type, if it is defined outside, you can't change it inside some other function. If you want to change it, you have to refer it from inside the function. Then comes mutability. What if you pass a list? So here you see I am taking some variable as the parameter, and I am basically appending to whatever that parameter is. I am appending a list 10, 20, 30. Value 20, 10, 20, 30. List value, basically you are adding 10, 20, 30 to the content of the whatever value you have received here, and then you're printing it inside it. So outside you have defined a list which has value 100, 101, 102. Then you are printing it, it will print 100, 101, 102. You are passing it inside the parameter and appending it and printing it. It prints the appended value. Once you return, you come out of the function, the data is changed because the data type what you have used here is a mutable data type, which is a list, right? So you can change it. It's mutable. That's the reason. So passing parameters, you can pass parameters in 3 4 different ways. Formal parameters inside the function, let's go look at them. The first one is called as required parameter. That is, if you have a parameter required like this, then you must supply a parameter while calling it. You don't have any other option. This is called required argument, meaning you must pass it. If not, you get an error, right? Then comes keyword argument. When you use a keyword while passing, if you don't want to pass it in the same order, that is, if you don't want to pass 101 first and then John, you can associate them back with the keyword. That is, customer name is equal to John, comma customer ID. Wherever you are associating them with the keyword name, right? The formal parameter keyword name. That's why it retains the relativity. As in, customer ID is copied here with, and the customer name is copied with John. Once you print it, you get 101 and John respectively. Default arguments. What if no argument is supplied, you want some default argument to be picked up, then you can assign, while definition of the defining the function itself, you assign some default value. Here, see, customer age is set to 30, and then you're printing the name and the age inside the function. Here, customer details you're calling. First time you're passing age 25, name John. It will print name 25 and John, age 25 and name John. And then you have function calling without an age. When you're calling without an age, automatically this age what you have initialized with, the default age will be picked up, called 30. So this will be printed, this will be printed. Even here the age will be printed as 30. So that's default arguments passing. Variable length argument. All variable length arguments In the variable length argument, what happens is, I'll show you rather with an example. See here, you give a tuple with a star, a variable name with a star. If you pass different number of more than required number of arguments, and in the receiving side if you have star variable name, then all these extra values, the first value is mapped to customer name, all these three values are mapped to a tuple called variable tuple. See here, for where in variable tuple I am printing it. So first time it and Harry. In the second call, I am only passing Mary. This Mary will be copied to customer name. Nothing is copied to where tuple. So only customer name Mary will be printed. This tuple, this for loop will not print anything. Right? So variably, you are passing parameters with a variable length. So that also can be done in Python. So this is about functions in Python. Right? So the scope of the variables and all that, the half-an-hour session of the Raspberry Pi. If we have some time in the last, I'll come and back and explain the scope of the variables. Right? I already gave you a glimpse of variable scope with the earlier example. String module, upper is digit, all that I explained. Small another thing that I want to explain here is there are some additional modules that you can actually import from Python into Python program, like math module, time module, date module. You can basically import them. Please give me a moment. Yeah. By using, see, ABS, seal, complement, exponential, flooring, max, min, power, round, square root. You can basically use all these kind of functions. They are not literally if I run this, fire is my output. Yeah, 5.0 as my output. It calculated the square rate automatically. Right? I can import outside libraries like this, like how we do hash include. Right? I can rename it as M, meaning I can use, right? So, or if I want very specific, imported. For example, from math, you're using import sqrt. Here, instead of mat.sqrt, you can directly use sqrt, right? Because you're telling from math, you import sqrt, you can directly use sqrt. You can like this. These are the two ways you can import three ways. You can import library in Python. This is date and time module, the current time in seconds. Then you have on your end what is the time, sleep. You can basically make your program to pause for a while also. This, guys, covers the Python part of today's session. Let's start with the Raspberry Pi. Important, as interesting as possible. Please bear with me. Just give me some half an hour time. Right? We have Raspberry Pi. What is Raspberry Pi? Raspberry Pi is a credit card sized single board computer. That is, you have a small IC on which you have the complete computing power inside it. You can plug in a display unit like TV or keyboard keyboard or monitor, or you can plug in mouse and keyboard, and it becomes a complete computer for you to use. Right? It was developed by a foundation called Raspberry Pi Foundation with an intention with an intention to spread basic computer science knowledge in the schools and developing countries. However, that was the reason why they started to build, but it burst out, as in it went beyond the need, aim of the development, and people started using Raspberry Pi for several applications like building robotic applications, automation applications, and etc. And thereby Raspberry Pi went on with a huge success. Now the yeah, it went on to become very popular than anticipated. There were, in the initial year itself, 5 million Raspberry Pis were sold. Uh, and in 2016 November, just imagine the scale of it. So they're dealing with, why should we use Raspberry Pi? It's a small computer that you can keep it in your pocket. That kind of a computer with a very medium, very low price. The smallest compute unit of Raspberry Pi today costs 350 rupees. Average computing costs somewhere around 2000 rupees. I have here model A costs 1550, model B costs 2200. There is model 4B, which costs 2 GB RAM. For 2 GB RAM, it costs around 3500. 4 GB RAM costs around 5000, and spare another 2000, like 7000, you get 8 GB RAM Raspberry Pi, right? Currently, we are using a robotic application where we are using 8 GB RAM, 4 GB RAM to drive a Tata Ace kind of a machine, right? So that is the compute power that I'm talking about here. And it helps a lot to learn your programming, computer concepts, and embedded computing concepts, especially in areas where compute is a resource to be, very scarce resource. You can actually use to teach the Raspberry Pi to even school kids. The reason is, there is a programming language which is inherently supported by Raspberry Pi called Scratch, where you don't really have to write anything. You can just drag and drop and building blocks kind of a thing. Drag and drop different kind of structures to make the program, and run it. So that is the compute power that I'm talking about here. And it adds So that makes programming even more interesting for school children, and that ventures them into the embedded computing kind of area. So that is pretty easy, and it is cheaper because it supports wide range of operating systems, mainly it comes with an open source Linux OS. The foundation itself gives a OS called Raspbian OS, and you can run any free OS in it. You can also run proprietary OS like Windows 10 IoT kind of thing. Consumes very less power, right? 5 watts is the power that it requires, an input of 5 watt. You can power a Raspberry Pi using two AA batteries. AA battery is what you have, right, for your torches, small torches, what you use. That batteries is enough for you to power up your Raspberry Pi, or just our USB laptop USB port is enough for us to power it. Then it supports full video audio. You can basically connect it to peripheral devices, lot of peripheral devices. Basically, this credit card size device equal to this CPU. That's it. That's what I was trying to convey here, right? What are the features of this Raspberry Pi? Different models are there: Raspberry Pi Zero, Raspberry Pi Pico, Raspberry Pi A, B, 3, 1, 2, 4. The recent one is Raspberry Pi 4B, which is which is pretty hefty compute machine, if you ask me to say, right? All these models, they have an integrated system on chip, that is integrated processor, ARM processor, CPU inbuilt on it. They all have CPU speeds ranging from 1.2 to 1.6, I think, if I am not wrong. The model 4B has 1.6 gigahertz, 256 MB RAM too. 4B has 8 GB RAM, right? And it also supports SD card storage, not just the RAM. You can store permanent programs. It supports a micro SD card, of different sizes, 64 GB, 180 GB. You can support. It will support, and it has USB slots, many USB slots, depending on the size of the Raspberry Pi or the type of the Raspberry. You can connect it to any video device like TV, laptop screens, or desktop monitor. It also has a speaker jack, 3.5 mm jack, where you can give audio output. And the beauty of Raspberry Pi comes into this last statement, where it has several GPIO pins, meaning general purpose input output pins, which is my stress upon this today's demo, today's program. So I'm going to skip through and show you the direct GPIO execution part, right? Yeah, features like you can connect to Wi-Fi, you can connect to Bluetooth, you can connect to Ethernet, that is LAN cable. It has support to various languages, various operating systems, right? So basically, it's your pocket sized, or it is your own pocket laboratory, or it is your own pocket computer, right? It has different processes and different caches. I'm going to skip through it. You can refer the documentation of it. uh, this is a picture. This is the actual picture of the Raspberry Pi board, a credit card size it is. Model 4B, Pi 3 model B. So if you see here, it has an USB, two USBs here, two USBs here, Ethernet jack where you can connect your LAN, HDMI output where you can connect any monitor, a camera slot where you can basically connect a camera, a Pi camera that you get in Pi Foundation, micro USB as your power input. You can connect to any display DSI monitors as well. This is your CPU here. This is the CPU, and this is general purpose input output pins, where you can, these pins you can use to combine lot of sensors or hardware devices in order to perform some kind of electronic programming. You can use these pins to provide input to Raspberry Pi or take output from Raspberry Pi, right? I will be discussing that. This is Raspberry Pi Zero. It has limited features. It doesn't have much USB. It has an micro SD slot here. This, there is a processor, GPIO pin, two power, one micro USB. This is the OTG USB. There is no support to USB 2.0 or 3.0. This is the power slot, and then you also have a HDMI output. Right. This is Raspberry Pi Zero, and this is the latest version, Raspberry Pi 4B. This is the power. This is the Type C USB power. The Type C cables that you have, you can give power to this Raspberry Pi using this. Then these two are the two, you can connect two display units here, audio jack, Ethernet cable, then you have LAN cables, USB cable. This is your RAM, this is the processor, right? And this is your Bluetooth and wireless connectivity. This functionality is inbuilt in it. Come on, my PPT got stuck. Am I audible, Shubhashini ma'am?
Yes, sir. We can hear you. Yeah.
Hello?
Hello? Hello?
Hello. You are audible. Hello.
Uh, Hello?
Yeah, you are audible.
Hello? Sir, can you hear me?
Hello. Hello. Hello.
Hello, sir? Sir is joining, so 1 second. Yeah.
So we have SD card slot, audio jack, power slot, and this is our GPIO pin. These are male pins. That is, you have some kind of sticks out where you can plug in jumper wires, right? Now, how do we power it up and run? We basically connect USB keyboard, USB mouse, or Bluetooth keyboard, Bluetooth mouse. Plug in audio jack if at all you want to. Then install, take an SD card, format it. There is something called as Raspberry Pi SD card. If you go to this raspberrypi.org, you have it will copy OS into the SD card. You can refer to that. Once you have your OS up and installed in the, and connect the display. That is, you can use a HDMI card and you can plug it into your laptop, or you can put it into micro HDMI, and you can put it to any monitor device. If you don't have HDMI support to the devices, you will have to buy a connector converter from micro HDMI to HDMI or VGA converter. Then you can plug it into your laptop, or you can put it into any monitor device. Once you have your OS up and installed, hi, am I audible now?
Yes, sir. It's audible now.
Okay, thank you, ma'am.
Yes.
Right. So, as I will specific functionality, each pin here have a specific functionality, and these functionalities vary from model to model. So, whenever you are working on a specific Raspberry Pi model, it's important for you to know the pin numbers and what functionalities do they have. Right now here, if you see pin number 1 in this model 4 Raspberry Pi layout is a 3 volt supply output. 2, 3, 4 are control general GPIO pins. I can use it to take input or output, right? And black one, this 5 here, what I have, sorry, this black one is basically not 5. This is ground, right? So like this, you have a layout associated with every model, right? So in this case, this button, it is a output supply of 5 volt. So if I connect anything to this pin, right, it receives 5 volt input from the Raspberry Pi. So you basically can build circuits using this GPIO headers and control these circuits using program. How to do that? I am going to show you with a small example of blinking and LED. let's connect an LED light to this Raspberry Pi and try and see how to make it blink it, right? Now there are 40 pins, and these pins can be used in any way to control them, control your input and output. You can control build circuits by supplying constant voltage, or by taking input from a sensor, or giving output to a actuator, or connecting ground to a sensor or an actuator or a light kind of a thing. You can do all of these things using these input output pins. Now, let's look at blinking an LED program. What do we require here? We require a Raspberry Pi, of course. We should know the complete understanding of the layout here like this, right? Here I am assuming a Raspberry Pi 4B, model 4B. Then we need an LED light. We need a small resistor, somewhere around 330 ohms probably will do. And then these jumper wires. This is a male. There is a stick here, male to female jumper wire. And so you have combinations you get in bulk. In Amazon, you can go and order bulk. Hundreds of jumper wire comes together. Hardly 100 200 rupees it will be. You get hundreds of them. Male to male, female to female, male to female, female to male kind of combinations you will get. Those, all of them will come in handy for you to build circuitry. And then you also need a breadboard here like this. What is this breadboard? Breadboard is basically an integrated small metallic board which helps you to, you don't want to connect different components, plaster them, connect them, ensure that they are not broken. These kind of things you don't have to do it if you have a breadboard. This breadboard have several pins where you can just plug in components. You can take this resistor, put it inside a block here, put the other side inside. There you go, you have placed a resistor in the circuit. You can do like that, right? And the layout of this breadboard is these end lines, what you see, they are connected like this vertically. They're all connected. So you can connect multiple components into the same line here, right? For example, into this 5 volt, if you connect a plug here, then you can connect multiple components to this to receive 5 volt input. The end lines are vertically connected. That's what I want to say. Then we have these horizontal lines. These are horizontally connected. Basically, if you connect, see, this is a horizontally connected line. This is horizontal. These 5 are horizontally connected. Like this, you have each row horizontally connected. If you connect one here, one component here, and one more component here, they both are under same line. They are under same connection, right? However, if you have a connection here and if you have a connection here, they are different connections like that, right? So that's the alignment of breadboard. Now let's go and build the circuit, how we place an LED into this, right? So I told you already, you have a Raspberry Pi connected to keyboard, mouse and everything. You have a display connected to it. Now let's take an LED. A LED will look like this: one short wire and one longer wire. Here I have a real image. If you see, there is a longer wire here, there is a shorter wire here. The shorter wire always means it is neutral, as in it is ground. The other one is a positive volt. You use a resistor here. You see here, I take a jumper wire, plug into the first GPIO pin, which represents 3 volt input, right? Directly, instead of connecting it to the LED, I am taking a small resistor in it, right? This resistor is connected just to avoid the voltage fluctuation. We don't want the LED to draw more power Raspberry Pi. So we want to regulate the voltage being supplied here. So we'll use a resistor. So we connect ground. The smaller pin is connected using jumper wire to ground, and the longer pin is connected to the positive pin here through a resistor, right? Basically what you do is you take this pin, you plug in here the first pin, then here you place the resistor and you plug the resistor back here, right? Then here you take the positive side of the LED. Then to the ground side you will connect to some breadboard here, and another jumper wire you will take here and you will put it to ground here like this. So that's what we mean, right? So how do you connect it is this way. That's the connection that I wanted to talk with respect to LED. Now, since we are connected, we have connected. As soon as your Raspberry Pi powers up, your LED starts switching on. It turns on, right? You are continuously giving a 3-volt supply to LED. Now, your Raspberry Pi is taking the power from your power source and it is giving a 3-volt output to the this pin of the LED, and the circuit is closed with the ground here. This LED will light up. Now, with this setup, let's go and make it blinkable using programming. How do we do it? Now you take this, instead of connecting it here, you can connect it to any GPIO pin, general purpose pin, that is 17, 18, 23, 24, like that. Any pin you supply, just that in the program you have to refer using that corresponding pin number. So I am going to take this blue connection from this constant supply and I am plugging it in to this GPIO pin 25, number 25, right? Now by GP25 here can be manually turned on and off, right? I can give output here, I can give input here, I can take input here depending on however I want it. So I have LED connected to 25. Now if I want to turn on my LED, I will give supply through GPIO 25 port. That turns on my LED. If I want to put it off, I'll cut down the supply. Do I actually give the supply on and off? No. I use again libraries in my Python programming. GPIO control has a library specifically associated with it called GPIO 0, where you can refer any of these ports and make them to act according to your vision will. So now I have this setup. I have ground set to LED and the positive of that is set through the resistor to GP pin 25. Then in my Python desktop, I will go to the screen, in my Raspberry Pi desktop, I'll go to the desktop screen that I had shown already. I'll create a small file called LED blinking.py. There I will write the key, the program. First line I will use is from GPIO which is given by the community for you to be able to access Raspberry Pi, right? So from GPIO 0, you are importing a variable called LED, small letter LED, this LED. You are telling LED 25. That is port number, pin number 25 is where you have connected your LED, right? Now by using these two lines, you have told your Python program that listen, I have an LED functionality to be utilized, and this is being controlled using pin number 25. Okay. Now I can control on and off using LED on and LED off. If I give LED on using pin number 25, your Raspberry Pi will supply voltage, LED will switch on, LED dot off will cut down the supply, LED gets off, like this. On and off you can do, right? So if you write this with a small, like if you write these 4 lines in the Python and if you execute it, right, in your command prompt, Python shell, if you execute this program, led.py, if you execute in the Python shell, then the LED quickly turns on and off. You won't see it actually, it just quickly turns on and off. So you want that blink to be seen. Therefore, you need some timing to be given. If you want it to continuously switch on and off and on and on and this, you are importing sleep function from type, where you make the program to sleep for whatever time you want. You are importing GPIO 0 with LED functionality. You are initializing the pin number 25. Then in the while loop, look the indentation here. This is the body of the loop. Right. So I am turning on the LED. So this passes pin 25. It passes the voltage. Then for 1 second. Then I'll turn off the LED for 1 more second. Then while is true. So I'll keep on doing it until I force close my program. So this will blink my LED continuously in my using my Raspberry Pi. So this program in connection with Raspberry Pi, Python and LED circuit will enable you to blink LED continuously on the breadboard. So this is a simple example for you to interface a hardware tool like a LED bulb with the Raspberry Pi, and with the power of Python, you are making all of them to come together and listen to you and blink it according to your tune, right? So this is a small example to demonstrate Python. This guys have been talk, and I'm done here. So I hope you guys this talk made you to get interested in Python and Raspberry Pi in general, and I hope you guys will explore it further. Please do explore Raspberry Pi and Python. It will help a lot, even in terms of your career, as well as, as a computer science engineer, you get to learn a lot by doing this, right? Thank you all. Have a good day. I am open for questions if at all you have any.
Yes,
I'm
sir.
extremely sorry for consuming more time.
Sir, no
Yeah.
problem, sir. No problem.
Any questions students are asking? Just
Yes, sir. Sir, regarding related to Raspberry Pi, students are asking like they are comparing it with Raspberry Pi and Arduino. Like in what situations Raspberry is recommended is the question, sir.
Okay, so Arduino is basically voltage supply and not. That's all. It's a microcontroller. It is very much limited to specific embedded computing devices, right? When it comes to Arduino, Raspberry Pi, it's the whole computer. It has a general purpose processor. It's not a microcontroller, right?
Yes, yeah.
It's
Sir, and
you
one more thing,
have
like
wide variety of applications that you can create, with respect to it. Yeah. Yes, ma'am.
yes, sir. Sir, and one more thing, like one student is asking, does Raspberry Pi,
Hello.
what operating system does it have? I think you have already told it, Raspbian. Yeah. Sir, and one more question is like Raspberry Pi,
Yes.
does it have its own memory inbuilt?
Raspbian, any operating system that is supported by a device.
Yes, sir. Sir, and one question is like, does Raspberry Pi has its own inbuilt memory?
Yes, it has a RAM, but not a permanent memory. So as permanent memory, you have to plug in a SD card, right? SD card is the permanent memory. That is when you save a program or something, it will be saved in the SD card. You can plug it that SD card into your laptop. You can change the items in it. You can test something and then plug it into Raspberry Pi. You can do all that. It has an inbuilt RAM, but not permanent memory. You have to secondary memory. You have to supply it through
Yes, sir. Yes, sir. Sir, and one more last question. Like students are like, if can they purchase the whole kit of Raspberry Pi in the market or through online mode like Amazon or Flipkart?
I don't get you. I didn't get you, ma'am.
Sir, actually, they
Yeah,
are
we can
asking like,
purchase.
can
Could
they
you repeat your
purchase?
question?
That's the question. Will they get the whole kit available? Yeah.
Oh yeah, they can purchase. Recommended purchase is through this raspberrypi.org. There, what happens is when you want to buy, they give official suppliers website is what they give. You can go to those suppliers and you can buy it, or through Amazon also you can buy it. It's just that reliability that matters. So we can't trust all sellers. You just have to be aware of the sellers. If you go through Raspberry Pi organization's official website, the
Yes, sir. Yes, sir. I think that is it, sir. That's all the
any more
questions for
questions, ma'am?
this. That's it, sir. That's it. It has covered up all the questions. Yeah,
Okay.
sir. Essentially,
Uh, uh, Karthik, it's
Okay.
well done, and I would like to
Sir,
thank you. And also,
thank you, sir.
I like to thank Manoj and your vice principal and principal because just in the
Of
last
course.
moment I asked Manoj, and also convey my wishes, my regards to them. And
Yes,
also, you have spent during your busy schedule because of you have
definitely, sir.
second test and you had some spare time. That spare time is supposed to spend with your during lockdown with family, but however, utilized your time. Okay, thank you, and also thank the entire team of your support. And also, I thank Subhashini and also
Not a
students
problem, sir.
actively participation and make use of this. And also, the Raspberry, either this IoT, it has lot of scope in the future. You must learn Python and applications. Then you will have a lot of scope in the upcoming days because whatever Amazon, AWS today devices to connecting and maintaining the Python it will be used. So learn properly and make use of this technology and also get ready for your upcoming test. Thank you one and all for being with 2 days, almost 5 hours. Thank you Karthik once again.
so thank you, sir. Thank you, Karthik, sir, for
Thank you,
spending your
Chandrasekhar,
valuable
sir. Thank you,
time.
Shubhashni, ma'am, for
Yes,
coordinating.
sir.
Thank you. Thank you.
Yes, sir. Thanks for your valuable time and
My
your
pleasure, ma'am. My pleasure.
giving us the
Thank
knowledge
you for
about the
having me here.
basics of Python. Yeah.
Yeah, I'll send a letter, Karthik. Yes,
Yes. Sir,
once
thank
I
you.
go to college,
Thank you.
I'll get a thanking letter. I'll
Definitely,
send.
sir. Not a problem. Sure, sir.
Yeah. Okay, thank you.
Yes. I'm even
Sure, sir.
thankful to our
Sure. Thank
HOD,
you very much,
Dr.
sir.
S. N. Chandrasekhar,
Thank you, one
sir.
and all. Have a good day.
Yeah.
Yeah. Thank you, sir. Our HOD, Dr. S. N. Chandrasekhar, sir. Thanks for making us having arranged with all these things. And thanks for your support and encouraging us always in doing such activities. Thank you very much, sir.
Thank you.
And I thank all the students for your participation. Please keep your interests the same way and try to explore more about the subject or well any other technology. Yes. So with this, we are going to end the session of our 2 days workshop on IoT physical devices and endpoints. So, thank you all.
Thank you, one and all. Have a good day.
Yeah, yeah, thank you.